Differentiation is a fundamental concept in calculus that refers to the process of finding the derivative of a function. The derivative represents the rate at which a quantity changes. In simple terms, it measures how a function's output value changes as its input value changes. For example, in physics, the derivative of a position function with respect to time gives the velocity. And now, what are the techniques of differentiation? There are 9 techniques used to differentiate functions depending on their form. First, power rule. Second, constant rule. Third, constant multiple rule. Fourth, sum and difference rule. Fifth, product rule. Sixth, quotient rule. 7, chain rule. 8, implicit differentiation. 9, logarithmic differentiation.
Next, we will continue with question 2a and 2b. Question 2a. Given that y equal to cube root of x tan 3x, let u equal to x power of 1 over 3, u prime equal to 1 over 3 x power of negative 2 over 3, v equal to tan 3x, v prime equal to secant square 3x times 3 equal to 3 secant square 3x. Using the product rule, that is u v prime plus v u prime, insert the value. Insert the value of u v prime plus v u prime. Expand the equation like shown. Lastly, in the final answer, change the power into third form.
So now moving on to the question 2b. So the question is y equals to ln x over 3 minus 2x. So we will use the quotient rule. So the u is ln x and u prime will be 1 over x. So the v will be 3 minus 2x and v prime equals to negative 2. So we will use the quotient rule. So now apply the quotient rule. Now, we simplify the numerator. After we simplify the numerator, we need to distribute the 1 over x. After we distribute the 1 over x, we can get the final answer.
Now, let's proceed to question 3, which is find dy dx using implicit differentiation method. The question given is e to xy minus sin y minus 1 equals to ln 4x minus 3. Differentiate e to xy, you get e to xy times 2xy, which is you need to differentiate that equation also using product rule. Differentiate sin, you get cos y times dy dx, and differentiate ln 4x minus 3, you get 1 over 4x minus 3 times 4. To differentiate to xy, let u equals to 2x, v equals to y, which is u prime, you get 2, and v prime, you get dy dx. Then you combine all the differentiate equation that you differentiate just now. After that, you expand e to xy into the equation that we have used the product rule method just now. Then you put the equation with dy dx on one hand side and without dy dx on another one hand side. After that, you factor out dy dx on the left hand side. And now you get the answer like given as shown.
Question 4. We are given the expression the cube root of 63.99 plus 1 divided by the square root of 63.99. To estimate this, I define a function s. F of x is equal to x raised to the power of 1/3 plus x raised to the power of negative 1/2. That is, f of x equal x to the power of 1/3 plus x to the power of negative 1/2. To apply linear approximation, we must find the derivative of the function. The derivative of f of x is f prime of x equals 1 divided by 3 times x to the power of negative 2/3 minus 1 divided by 2 times x to the power of negative 3/2. In word, take the derivative of x to the power of 1/3, which is 1/3 times x to the power of negative 2/3. Then take the derivative of x to the power of negative 1/2, which is negative 1/2 times x to the power of negative 3/2. We are given that the actual value of s is 63.99. The reference of estimate point is 64, the close one. So the change in s or delta s is delta s equals 63.99 minus 64, which is equal negative 0.01. f of 64 equals 3 multiplied by the cube root of 64 plus 1 divided by the square root of 64 equal to 4.125. Next, for the derivative, f prime of 64 equals 64 to the power of negative 2/3 minus 1/2 times 64 to the power of negative 3/2 equal to 0.02. Now we apply the linear approximation formula. F is approximately equal to f of x naught plus f prime of x naught multiplied by delta x. Substitute the value. F of x naught is 4.125, f prime of naught is 0.02, delta x is negative 0.01 equal to 4.125.